Różańska, except Marta will be presenting from the video.
Yes. Good morning, everyone. Today with Marta Różańska, we would like to present you the main concept of melodic and morphemic projects, and the main concept which is management of multi-cloud application. Unfortunately, Marta can't join us today live, but she prepared a video for you, and we will start from this theoretical part, and after that I will show you the live demo of our platform.
Good morning, everyone. I'm happy to join you online today. I'm Marta Różańska, and I'm a PhD student at University of Oslo and R&D developer at 7bulls.com. Today, together with Alicja Reniewicz, senior full-stack developer and team leader, we would like to show you the tool that can perform autonomous multi-cloud deployment of cloud applications. The platform is called Melodic. Melodic can be seen as a middleware between cloud applications and cloud providers. The goal of the Melodic project is to simplify cloud application modeling and to continuously optimize the cloud applications in the multi-cloud environment. It is open source, so you can try it for free and you can also contribute. Let me tell you some details and important concepts of Melodic. It is a simple and easy tool and easy way to use multi-cloud approach. Generally, the optimization of the application is a complex task that is impossible to be handled manually by human. There are too many offers and possible application configurations. As I mentioned before, Melodic is a management tool that can work as a middleware and support the optimization process of cross-cloud applications. So Melodic can deploy application automatically to different cloud providers and various types of the application components, including virtual machines, containers, serverless functions, FPGA, and edge nodes. For now, we support OpenStack, AWS, GCP, and Azure deployment, but we work on adding Kubernetes management as well. What's more, when the application is deployed, Melodic continuously monitor and optimize cloud application resources. One of the most important features of Melodic is its intelligence, so the ability to find the best cloud application deployment. It is done by using constraint problem models and utility functions. The Melodic goal is to maximize users' utility by maximizing the utility function. You can think about this as the auto-scaling, but it's actually much more flexible. There are no scaling rules, just the goals described as desired metric values. So the platform makes the necessary adaptations to the deployment configuration as the demand changes. Now the question is, what's the best deployment? And that's a very good question. Melodic on continuous basis looking for the better solution for the deployment and makes this reconfiguration if newly found solution is significantly better than the current one. There is a huge research behind this concept, but this is a technical conference, so let's focus on features, not theory. Melodic collects metric containing information about the usage of resources and other important for the user information, often business specific. So the user, the application owner, can create a sensor or use built-in sensors, for example, for CPU or RAM usage, to combine the utility function. And the newest feature developed in Melodic extension called Morphemic is the execution context, so this metrics, prediction. It means that the application is optimized for the future runtime conditions thanks to the complex time series forecasting, methods implementation, and novel optimization techniques. So we don't only react on increasing workload. Melodic together with Morphemic is predicting when it happens and prepare the application to handle this bigger traffic before it actually happens. User preferences usually covers many aspects which are often conflicting. For example, one may want to minimize the cost, keeping the average response time quite small. If there are too many requests, there is a need to add more instances, but will increase the cost, which we want to minimize. That's the reason that there is always a trade-off between the cost and the performance. Melodic supports a very flexible utility function approach to ensure the best possible optimization of cloud application deployment. I will not go into details now, but just to mention that Melodic uses 5 solvers using various optimization techniques such as Monte Carlo tree search, supervised learning combined with reinforcement learning, parallel tempering, learning automata, and we use these algorithms with very good results. We published many research papers in this area. To work with Melodic, there is a need to describe the application model as a CAMEL model. CAMEL is Cloud Application Modeling and Execution Language, and it is used to model the application, so to prepare the input for Melodic. It is a domain-specific and cloud-agnostic, so cloud provider-agnostic language. It is based on Eclipse modeling framework, and it's similar to Tosca. It looks similarly to YAML. It covers all aspects of application modeling, so it is possible to model in CAMEL the application components, connections between them, also security aspects. It supports various types of application components, script-based, Spark components, Docker containers, GPU or CPU or FPGA nodes as well in the newest version. It allows also for complex infrastructure requirements modeling, like boundaries of resources needed by each component microservice. And what's probably the most important and unique, it allows for modeling of user preferences, utility function and constraints. It makes the optimization process in Melodic possible. As you can see on this diagram, CAMEL is built from modules. It currently contains many modules and it will have more because they are work in progress on extensions. But what's important to notice is the fact that these modules can be reused in more than one CAMEL application model. For example, in the Melodic, we have some predefined metric models that are reused in many application models. Also, the security model can be shared among many applications if it's needed. So, how does Melodic work? Firstly, user needs to create a CAMEL model for his application and set up initial parameters for the application. After that, Melodic starts the work. It downloads the offers from cloud providers that user has access. It calculates the best cloud environment for application and deploys it automatically. The reasoning part is done by, so the decision-making part is done by solving a constraint optimization problem, maximizing the utility function automatically generated from the CAMEL model. To solve the constraint problems, Melodic uses various solvers. Among others, a stochastic learning automata solver or based on reinforcement learning algorithms. Currently, Melodic supports deployment on big cloud providers like AWS, GCP, Azure, and also OpenStack. When the application is ready and working, Melodic starts collecting defined by the user metric about currently running configuration. So if the better solution appears or actual solution, so actual configuration becomes unacceptable because one of the constraints, the reconfiguration is triggered. So Melodic can move application components to another cloud provider, to another virtual machine. It can add more instances or whatever Melodic establishes as the best deployment for the current situation. Therefore, during the application execution, Melodic manages to always have the most optimal environment. Melodic is built from microservices, and components are deployed using Docker containers. We have the integration solution based on Enterprise Service Bus, Mule ESB. The orchestration of the data and the action flows within the system is modeled as processes, and we use Camunda as business process management orchestration tool. It's important to notice that some components of the platform can be, and actually are, reused in other projects, etc. So if you're interested only, for example, for the forecasting part, you can also try and check Melodic, because it's possible to use only some part of the services. The newest features of the platform are polymorphic and proactive adaptation. The goal of the polymorphic adaptation is to optimize the application's deployment by changing the application architecture at runtime. So scaling the application components not only in the number of instances, but also in the form they are deployed. It is possible, obviously, only when a component can run in different technical forms. So in particular, as a runtime decision, the platform decides which form or configuration of a component should be selected for the deployment to maximize the utility, the user's utility. The second feature is the proactive adaptation, which goal is to optimize the application's deployment for a future time point. This goal is particularly important from a practical point of view, because they are critical applications that must run with minimal downtime. Thanks to the proactive adaptation, Morphemic and Melodic can adapt application resources ahead of the time they will be needed to prevent situations that are critical and to ensure the expected performance of the application. Our platform, thanks to Morphemic extension, has a forecasting module that predicts future conditions and behavior of the application, and it's able to select the best deployment configuration for a time point at the needed time horizon in the future. So the workflow with Melodic is very simple. You as a user need to model your application in CAMEL and deploy the Melodic platform. Then you just need to submit your CAMEL model to your Melodic instance, push the big green button to start the deployment of the application, and observe. Thanks to the Melodic UI, you will be able to see the reasoning process of Melodic, but you're not expected to do anything more. So you can connect, relax, and enjoy your application working. Thank you for your attention. Just the last thing I would like to mention is that you can download Melodic at melodic.cloud. Thank you. Now it's time for the demo of the platform.
Okay. So after the theoretical part and background of the Melodic process, I would like to present you how it works in practice. Now we can see the main process view of the deployment of our simple test application. And now we can see that we are in the middle of this process. It is quite complex and time consuming, and because of that I needed to start the whole process during the Marta parts of presentation in order to show you also the effect of this process, and now we have time to better know the whole platform. Okay, so my Melodic platform is installed and configured on some virtual machine, and now it is up and running, and we can observe that it works now here. But in order to see such process view, we need to, of course, perform some configuration steps And now I would like to show you how to adjust the whole platform, how to and how to start the whole deployment process. Okay, so now I will show you the basic part, let's say, of each application. The list of users, of course. Melodic has 3 types of users, so we can create common user, administrator, and technical user. Technical user is not important from the business view because it is used only internally during the reconfiguration process. Melodic users are managed by LDAP. And during installation of the whole platform, we need to create our administrator, and after that we can add more users in order to share our platform. After that, it is time for configuration provider settings. As Marta mentioned, Melodic can connect to 4 basic cloud providers, to OpenStack, Azure, AWS, and GCP. But in order to do that, we need to provide cloud providers credentials, of course. So in order to, for example, deploy our application in AWS, at first we need to configure provider settings for this cloud provider. On my environment, I have already configured 2 cloud providers, so AWS and OpenStack, but of course it is possible to add more configurations here. In such configuration, we need to provide, of course, secrets, which are required in order to create, for example, virtual machines, serverless functions, or Docker containers. And after that, after these settings steps, we can go to the next part, so to the main part of the whole platform. So deploy application, which is named deployment here. The first step in Melodic usage, before performing the whole deployment, is to model our application. We have a dedicated language, which is named CAMEL. CAMEL language is used to model our requirements for our application, and also it is used to model metrics, which will be collected during the whole application runtime. After that, our CAMEL model should be transformed to XML form. XML form is a form which is understandable for Melodic platform, and we need to attach such a file here. In my case, I attached such model just before our meeting, and now we can see that it is stored in database, of course, after validation. After that, we have last configuration step. Here we need to choose which application we would like to deploy. In our case, it is Genome application. I will describe it in a minute. And after that, we need to choose which cloud definition we would like to use during our process. So, for example, if we would like to focus only on AWS, we choose only this cloud provider. Also, I performed such a step just before. But it is possible to choose here many cloud providers. And after that, we go to the last step, and here we can see this magic big green button. So we need to just only push this button, and after that, our deployment process will be started. Now I don't need to push it again because I performed it just before this demo in order to start the whole process a bit, for example, 5 minutes before the whole demo in order to finish on time. And after starting the process, we see the process view. So the view which is also visible at the beginning of my presentation. And now we can see that it is built from 5 main steps. And the first step here is fetching offers. So in this first step, Melodic collects available offers from previously chosen cloud providers. So in my case, offers from AWS. Here we can see the total number of these offers which are available for us during this deployment, and from these offers, Melodic will choose the best solution for us. Also, it is possible to see detailed view of our offers. So cloud means my configuration of cloud provider. So in this case, inside this cloud, we have my cloud credentials and some properties which I would like to use during the whole deployment. For example, if I prefer to create the whole application in some security group, I can put this requirement here. After that, we have list of hardwares and locations. So the physical part of our applications. For example, Melodic can create for us some virtual machine in some location. And last part here are images. Images means not only private images as we can see here, but also the whole list of public AWS images or images from some different cloud provider. Of course, it is possible to put inside our requirements that we would like to use some previously configured prepared image, and it will be also visible here in our available list inside our requirements. And after that, we have our application created from some dedicated image. Now we come back to our process view. And after fetching offers, it is time for generating constraint problem. Constraint problem means our requirements and model of our application. Here we can see our settings from CAMEL model, so from the model of our application. Now, during this demo, Melodic is being deployed for us genome application. GTM application is an application which performed parallel operations on human genomes and some calculations. So it is a big data application. In order to ensure quite efficient time and way of performing the whole calculation process, we need to perform these calculations parallel on many virtual machines. In order to provide the best configuration, we use Melodic and our metrics. This application based on Spark. Spark manages of the whole process and divides all tasks between Spark workers. So in model of our application, we need to model at first Spark master and also requirements for Spark worker. And after that, Melodic should ensure for us the most optimal number and parameters of these Spark workers. And here we can see in this simple view, we can see that our worker cardinality is from 1 to maximum 10, and we would like to have virtual machines with 8 or 16 workers. And also our requirement is to have exactly one Spark master, and both of these components should be created in the same cloud provider. It is possible to see the detailed view of the constraint problem. And here we can see again our variables, and below we have utility formula. It is one of the most important part of the whole calculations, because thanks to this formula, we tell to Melodic how it should calculate the utility of the whole solution. And also we have here list of constants, for example, maximum and minimum number of our Spark master component and also Spark worker component, and list of metrics. So one of the most important part in the whole calculations, because based on these metrics, Melodic knows if current solution is acceptable for us, or maybe it is needed to create some additional resources, or maybe some resources are not fully used and we can simply delete it in order to optimize our costs. Okay, and in our process view, we can see that the next step after generating constraint problem is deploying. Here, Melodic is reasoning. I'm sorry. Deploying will be after, of course, after reasoning. In reasoning part, Melodic finds the most optimal solution for us based on available offers and based off our requirements from constraint problem. And here we can see that now Melodic claims that the best solution will be one worker at start with 8 cores, and of course one Spark master. And after that, it is time for deployment of this structure. So in the background now, these virtual machines are being created for us. Okay, and we can see that this process is still in progress, but we can see some more technical view of this process, some details. In order to see it, we need to go to Advanced View, and we are redirected to Camunda because Camunda is a management tool for our process. I need to log in here with the same credentials are for the whole platform. Okay, and these credentials are even valid. And now we can see that we have one running process. This is our Melodic application deployment, and we can go deeper here in order to see each part of this process. Also, we can see here a list of our variables, constants from this process, and each step I need to a bit zoom in, and we can see here, okay, and we need to see here each step of this process. And now we are here. So after deploy, we are waiting for notification, and after that we have only one step update solution, and it will be the end of the our basic deployment process. And I named this basic because this is initial deployment, and after that, based on collecting metrics, it is possible to create another process which will be named reconfiguration, because based on metrics, Melodic can make a decision that we need to create additional resources or delete some of current ones. And in such situation, we will see a reconfiguration process. But now this is our initial deployment process, and even we can see that this initial deployment is finished now. So we can go to your application bookmark in order to see the result of this deployment. And in this place, we will see list of virtual machines created for us by Melodic. Also here we could see a list of functions in case of serverless application deployment. But my application requires only virtual machines, so here we can see our two VMs with Spark Worker and Spark Master. They are both in running state. Also, we have information about IP addresses. Provider, which is AWS in this case, and the exact location of this cloud provider. Also, in the last part, we have information about physical parameters of these virtual machines. So we have T3X large VMs for component with Spark Master, so one VM, and also for Spark Worker, we have T3 2X large VM. And both of them are created in US East 1 region. From this view, it is possible also to create SSH web connection in order to connect to these VMs in simple way. It is useful, for example, during testing process in order to search, for example, some problems, or simply in order to check if our application works in proper way. In case of functions, we would see, of course, name of this function, its state, provider, location, information about memory, runtime, and also location of such serverless function. Okay, so also now we can see here that we have some VMs, but we would like to check if these VMs are really exist. So in order to check that, we can go to AWS console. Okay, and I need to refresh this page, and I hope are in proper region. Yes, and here we can see these two VMs, which names starts with AWS prefix, and these virtual machines are our Spark Worker and Spark Master. Okay, so we can see that our application starts, our process starts, but now I go to the process view and we have some different process. So what is it? It is a reconfiguration process. Melodic claims that current solution was not quite efficient and makes a decision about creating a new process in order to provide for us additional worker. But in order to check why Melodic made such a decision, we can go to the monitoring part of the application. In order to collect metrics, to monitor these metrics, we use Grafana. Grafana is a tool for monitoring some statistics, and also it is used in our platform. At first, I need to log in, and each application has own parameters to measure, own metrics. So because of that, requires own dashboard. Also, we have dedicated dashboard for this application, and here we can observe the whole process of performing genome application. So now please let me describe what is visible on this particular chart. So at first we can see number of instances. Now we have two instances, two virtual machines, so Spark Worker and Spark Master. As also we have already seen in AWS console. Below we can see number of simulations. So it means tasks which are to perform by our genome application. And this number is decreasing by after performing next tasks. After that, we have values of our metrics. So we have not finished on time metric. Here we can check if our application maybe have sufficient configuration and maybe not finish on time. And we can see some points here. These points means our predictions, because as also Marta mentioned during during her part of presentation, Melodic not only react on real-time metrics values, but also tries to predict future values of these metrics. And here we can see some predictions. Also, predictions are visible here for metrics, which means if maybe we'll finish too soon, and also in numbers, of course, part. And here, this is, I think, the most important part in this dashboard. We can see here our estimated time and time left. Time left means how many minutes left from our time which are put in our requirements. And estimated time is calculated by Melodic based on our metrics. If our estimated time is higher than time left, and also if our number of cores is too low, or maybe if we can see that we not finish on time, there are signals that Melodic should create reconfiguration process and maybe create some additional resources for us. And because of that, we can see now that our previous worker with 8 cores were not sufficient, and maybe the more effective will be new worker with 16 cores, as we can see here in our configuration. Okay, so we can observe how Melodic works in practice, how it can manage of our application deployment fully automatically, and how it ensures for us the most optimal way of performing the whole application process. And that's it from my side. So thank you very much for your attention. And if you have any questions, I think that we have 3 minutes. So please ask.